All right, we've got a model and its train accuracy. However, to be able to use this model outside of Python, we don't need this black box. We want the nuts and bolts. In this Python SQL Tableau integration, the ultimate goal would be to create a function which can easily and reliably predict values from within Tableau. Since Tableau is a nice-looking manager-friendly software, that's the place where the end users of our analysis will likely take advantage of our model. Regression analysis, no matter if linear or nonlinear, is about determining certain coefficients, or weights, which we apply to the inputs to obtain a final result. So, to use this logistic regression model outside of Python, we must get our hands on the coefficients and the intercept. Moreover, in order to interpret this logistics model, we still need to do so. Let's get on with that. The intercept can be found very easily using the intercept method. reg.intercept_. You can already sense how we are going to find the coefficients, can't you? reg.coef_. Simple as that. However, this result does not truly get us where we want to be. We want to know what variable those coefficients refer to. We can get the coefficients from the names of our inputs column values. As I recall, we have this variable scaled inputs, which contains the inputs. Let's write scaled inputs dot column values and find them out. We receive an error message. It says that an ND array has no attribute columns. Of course, let's go back to our code. We standardized the pandas data frame unscaled inputs using the standard scaler. The result was stored in scaled inputs. This shows us that sklearn methods are compatible with pandas data frames, but whenever we employ some sklearn function, everything is transformed to ND arrays. That happened with the intercept, the coefficients, and obviously with the inputs. So, you should be comfortable with both data frames and arrays when doing machine learning with this library. This is another difference between sklearn and stats models. With stats models, almost all of the manipulations were going through pandas data frames. Alright, back to the coefficients. Now that we found out that the unscaled inputs variable was a data frame, we can use it to find the column names. Unscaled inputs dot columns dot values give us all the features we had. It's a good idea to declare a new variable that will contain this information, called feature name. Okay, I want to create a neat data frame that will contain the intercept, the feature names, and the corresponding coefficients. We can call this data frame summary table. For now, it will have a single column called feature name, and the data in it will come from the variable feature name. Now let's match those names with the coefficients themselves. Summary table coefficient equals NP transpose reg coef. This will create a new column called coefficient. Inside, we will have the information from the regression coefficients. Note that we must transpose this array because by default, ND arrays are rows and not columns. All right, there you have it. A nice and clean summary table with all the variables and their corresponding coefficients. The only thing we are missing is the intercept. There are several ways we can add it. Right now, the two alternatives that come to mind are using the append or concatenate methods. However, most methods will put the newly appended data at the end of the data frame. There is no prepend method, so what are we going to do? One way you can deal with this is the following. Let's add 1 to all indices of the data frame's summary table. So, summary table dot index equals summary table dot index plus 1. In this way, we will shift up all indices by 1. Now the 0th index is empty. Let's fill it then. Summary table dot lock 0 equals brackets intercept, and the function for finding the intercept. I'll specify the 0th element so we can extract a float rather than the whole array. Great! Finally, we sort the data frame by index and we get what we want. A true summary table. Everything is there and nothing is missing. In the next lesson, we will explore what these coefficients mean. Thanks for watching.